Hi everyone, my name is Avik. So welcome back to another lesson. So guys, if you remember in the last lesson we discussed about API. Okay. I told you like API is nothing but it is a contract between client and a server. Let's say if client is making a request, server is processing that request and it is sending back the correct response. But someone can ask you and they can say, "Hey, you developed this API. How fast is this? How fast is this?" Let's say if someone is saying, "Hey, our system can handle huge amount of traffic." What does this mean by huge amount of traffic? So all these things need some kind of name. Like this needs to be measured. Like how we are going to measure them. Like what is the definition of how fast is API? What is this huge amount of traffic? There should be proper nomenclature for all these things. So there is a vocabulary which we are gonna study today, and this vocabulary is very important for any kind of system design conversation, because how fast is your API? How much traffic my system can handle? What is the availability time of my system? Like this is a very basic conversation, and we uh, need to use some terminology by which we can define it. So this is a whole agenda of today's lecture. So let's start with something which we are calling as latency. Okay, which we are calling as latency. What exactly I mean by latency? So let's say you are having your client, you are having your server. A request is going from client to server and it is coming back from server to client. This is a request and this is a response. Now, what is latency is basically whatever time it is taking to go from client to server, server will process that request and it will send you back that response to client. So whatever time this whole thing is taking, this is nothing but latency. Let's say your client to server is taking 2 milliseconds to reach. Your server is processing that request and it is taking 5 milliseconds to process. Your server is sending back a response to client in 1 millisecond. That means what is my latency? My latency is nothing but 7 millisecond. Sorry, 8 millisecond. 5, 6, 7, 8 millisecond. So what is latency? Latency is nothing but it is the whole time taken for a request to go from client to server, server to client, like the whole time taken by one API call. Time, you can write it down. What is latency? It is time for one request end to end. What is latency? It is time for one request end to end. So now if someone is saying, "Hey, my API is fast," you can ask them, "Hey, if you are saying your API is fast, what is the latency?" Are you getting it? So this is a whole thing. Now let's go to another terminology, and that is throughput. Now, what is this throughput? Let's try to understand. Okay. It is actually nothing but it is work done per unit time. Let me give an example. Let's say you have your server. Okay, you have your server. Now, what is throughput is that how many requests your server can fulfill in 1 second. Request per second. How many requests your server can fulfill in 1 second? This is nothing but throughput. Let's say if your server can handle 10,000 of requests in single second, that means the throughput is 10,000 RPS. Because let's say you are having 10,000 users, okay, 10,000 users are using your platform simultaneously. Now all the 10,000 users are gonna throw the request to you at the same time. Okay. Now in single second, if your server is handling more requests at the same time, that means users are having good experience. But let's say if your server can only handle 5,000 requests per second, but in a single second you are getting 10,000 of requests, your server might get failed. User won't feel good experience. So this is a whole thing. Like how much work your server can do in a unit of time. This is nothing but throughput. Now, a lot of people get confused between this latency and throughput. They get confused. Okay, they say, okay, if latency is high, that means throughput is also high. I don't know, like they make very different kind of analogy and they confused very much. And I think to remove that confusion, I have a very interesting analogy. Okay. So let's say you are having a highway. You are having a highway. This highway is a 2-lane road. Like this is a 2-lane road. Okay. You have your city A. You have your city B. Let's say there is one car. This one car wants to go from city A to city B. Okay. Now, whatever time it is taking to go from city A to city B is nothing but latency. Let's say it is taking 1 hour. So from city A to city B, it is taking 1 hour to travel that distance. Okay, that is what we are calling as latency. Now let's assume I am adding a toll tax in between. There is a toll plaza in between. Now, what does this mean is that, let's say if I ask you, hey, how many cars, how many cars this toll plaza can handle in a single second? That means in single second, how many cars can pass through it? If you're saying, hey, 1000 cars can pass through it in a single second, that means the throughput of this highway is 1000 cars per second. Are you getting it? Are you getting it? Now, how can we increase this throughput? Can you just tell me, if we want to increase this throughput, how we can increase that? Of course, we can make a new road. If we are making a new road or if we are making a new lane, that means now more cars can pass through it in a single second. So earlier, if 1000 cars were passing in a single second, now it is 1500 cars can pass through it in a single second. Now tell me, we have increased the throughput. Is there any difference in latency? No, there is no difference in latency. Why? Because one car is still taking the same time to go from point A to point B. There is no change in latency. That means there is no dependency between latency and throughput. They both are independent terminology. I hope you got it. Okay, so you know what? Someone can also increase the speed of their server by increasing the throughput. Now, what I mean by throughput, let's say if earlier they were having a server 1, if they can add 2 server, now 2 server can handle more requests. That means more user can have good experience. That means in this case also they have improved their system. Are you getting it? So let's say if someone is asking, hey, we have significantly improved our system in terms of speed. Now, this is a very interesting question. You can ask, hey, what exactly you mean by speed? Do you mean about latency or you mean about throughput? Because both of these things can actually determine how reliable or how much efficient your system is. So I hope you got this terminology, and people confuse them a lot. And I hope you won't be able to confuse now because this example is pretty much legit. Now, let's take one more thing. Okay, let's try to understand one more interesting example. Okay, let's say you are having your system. Let's say you are having your system. Your system has in a single day 100 requests. Out of this 100 requests, 99 requests take around 20 milliseconds to process. Okay, like 99 API requests are only taking 20 milliseconds of latency. But there is one request which is actually taking 2000 milliseconds, which is actually 2 seconds of latency. Now, if someone asks you, hey, how fast is your API? So how will you calculate it? Because you are seeing 100 requests. Okay, you are seeing 100 requests. What exactly you will tell them? Like, will you tell them 2 milliseconds is your latency, or you will tell them 2 seconds is your latency? Like, how will you tell them? Like, or you know what? Many people think, hey, we can just find the average here. Like, we can just find the average here. So what is the average? Like, say 99 requests are taking 20 milliseconds, one request is taking 2 seconds. So average is coming around 40 milliseconds. So you can tell them, hey, our average API speed is 40 milliseconds. But tell me honestly, is average good way to measure the whole system speed or the whole system, efficiency? No, not at all. Because just imagine if you are having like, what does this one mean? Like if one API request is taking 2 seconds, that means 1% of your whole system is taking 2 seconds to response. Now just imagine if you have 1 lakh user. And if 1% user are facing this 2 seconds of delay instead of 20 milliseconds, this is a huge impact. That means around 1000 users, correct? 1000, no? Yeah, that means around 1000 of user are actually taking 2 seconds of delay. And this is not a good experience. This is not a good experience. So that's why we say even 1%. In this example, you were saying, hey, there is only one user. But no, if you just see this in terms of a big companies which have billions and billions of users, 1% is actually a huge number. So one thing we have got like that is average is definitely not a good term to measure some kind of response time of our system. It is not a good terminology. So now what is that terminology? So that terminology is nothing but percentile. It's like what is, I'll explain you everything, but just bear with me. What is this terminology? Instead of averages, we will use percentile. Okay. Now let's say if someone is saying, hey, let's just give an example. Okay, I gave an exam, and in that exam, my percentile is 99 percentile. 99. This is not percentage. This is not percentage. This is percentile. If someone is saying, hey, your percentile is 99%, what does this mean? It means you are in top 1%. If 100 student, let's say if 100 student have given the examination, you are actually rank 1. Why? Because 99% people are below you. Okay, 99% people are below you. You are in the top 1% if your percentile is 99%. Okay, so what exactly this mean? So in this scenario, if we are taking, let's say, this percentile method, then what does this mean? So then we can say, hey, P90, I'll come back to this later, but let me explain you how exactly we can write. So we can write a different way. Like we can say percentile 50. We can say percentile 95. We can say percentile 99. We can say percentile 99.9. And each thing can have its own value. So let's say if someone is saying, hey, my 50th percentile is nothing but, in my system, the 50th percentile is nothing but 40 millisecond. That means 50% of the calls are getting fulfilled in 40 millisecond, but rest of the 50 are actually taking more than 40 millisecond. If someone is saying, hey, my P95 is, let's say, 100 millisecond, that means 95% of the calls are getting fulfilled under 900 millisecond, but 5% of the call are taking more than, like, what does this P95 means? This means 5% of calls taking more than 100 millisecond. 5% of calls taking more than 100 millisecond. If someone is saying, hey, my P99 is 1 second, that means 1% of call are taking more than 1 second. Now it can be anything, like 1% can be anything. It can be 2 seconds as well. So now tell me, if someone is saying, hey, my P99 is 1 second, so that means it is a good terminology to understand how reliable or how fast their system is, because you can easily say, okay, so that means 1% of user are having a network call of more than 1 second. So what does this mean? What does this mean? Now this means, let's say if you're having 99.99999, the more the nines after this decimal, and let's say this is 1 second, the better it is. If someone is saying, hey, my P99.999% is actually only 20 millisecond, this is actually very good. Why? Because you can see, okay, that means only 0.001% of user are actually having a latency more than 1 second, or sorry, more than 20 millisecond. This is acceptable. But P99, it might not be acceptable. So instead of average was only telling you this 40 millisecond is the average thing, but it is not giving you the clear picture how many users are actually having a problem. Okay, so now if I tell you in this example, I can say, okay, my P99 is actually 20 millisecond, because 99% of the call are less than 20 millisecond. But if someone is saying, what is the value of P99.9 here? It might be 2 second. It might be 2 second. Are you getting it? So the more the number of nines at the end of this decimal, and the lesser this latency, it is better, it is good. That is the whole agenda of all the engineering teams. And to make this thing on paper, or to implement this thing, is actually takes a lot of effort. So now one more thing is that, let's say P50, P60, P70, P80, P95. The more this number is, the higher the latency will be. Let's say if someone is saying my P50 is 50 millisecond, that means 50% of the call is more than 50 millisecond. Now someone is saying, okay, then it can be like P60 can be 70 millisecond in this case. P70 can be 100 millisecond in this case. P80 can be 110 millisecond. P95 can be 1 second. So the bigger this number is, the better clarity we are getting. So that's why we always target to see this number as a bigger one. So we instead of quoting even P50, P60, we try to quote what is our, let's say, P99, or let's say what is our P99 value. Why? Because P99 is actually communicating us very interesting insight. It is not hiding any kind of false behavior with us. So if someone is asking how fast, what is the latency of a system, you just need to quote what is your P99. That means 99% of the user How fast is API for them? And what is the 1%? Like if you're saying my p99 is 1 second, that means 99% of the user are getting the request in 1 second. 1% is actually taking more than 1 second. I hope you got it. And this thing, like the higher the percentile value is, this also has name which we call as tail latency. So let's say P98, P95, P99, like all these percentile are at the end of the graph. Okay, so these are basically the tail. So whenever someone is asking about the latency, you only have to quote the tail latency, because that will give you the clear picture what is the actual latency of your system. So this is a term which we are calling as tail latency. Okay. Now let's discuss about one more terminology, and that is availability. Availability. Definition is simple. What is a percentage that your system goes live means, let's say in single year, let's say in 1 year, how many days your system is live. If you're saying, okay, my availability is 50%, that means in single year, half of the year your system is down. Like people is not able to access it as well, which is actually very wrong. So I know it is not even possible, because most of the time availability calculated on the number of 9. Like number 9 is a very popular number here. Like what exactly I mean by that? Let's say if someone is saying, hey, my availability is 99%. On paper, it looks very good. Okay, your availability is actually 99%. But just imagine if you're saying, hey, my availability is 99%. Now let's try to rotate down number, okay, in 1 year. In 1 year. Okay, if someone is saying my availability is 99%, what does this mean? This means almost 3 to 4 days, your system is down. Out of 365 days, 3 to 4 days, people are not even able to access your platform. Dude, this is actually a very big thing. Now, just imagine these 3-4 days are of Christmas days or holiday days. In these things, in this time, people used to shop a lot. Now, let's say you are operating an e-commerce platform and you're saying, hey, my availability is 99%. That means 3-4 days it can be down. And let's say those 3-4 days are of a Christmas holiday days, then your whole business can get hampered by this. So even 99% availability time is very bad here. Okay, now let's say if someone's saying, hey, my availability is 99.9%. That means around 9 hours your system is down in a single year. 9 hours is also a very big number if you see. Let's say you want to having some bank transaction, and in your bank transaction is happening in those 9 hours when the system is down. Just imagine the feeling that customer will have. Why it's not working? Even the 99.9% mark is not good enough. Are you getting it? Now, what does this 99.99% means? This means around 50 minutes. You have a downtime of 50 minutes. If someone is saying, hey, my availability is 99.999%, what does this mean? It's saying my downtime is only 5 minutes. Are you getting it? So the more the number of 9s at the end, the better your availability is. And you might be surprised. You are saying, like, just check it out. Between 99 and 99.999, the difference is huge. 99% means 3 to 4 days of downtime. And the more the number of 9s at the end, the lesser the downtime is. So all the companies, like, you know what is the difference between this 99% and this 99.99%? This is nothing but this is, let's say, your MVP, and this is a full-fledged production ready code. This is a difference of day and night. Like people spend, like engineers spend huge amount of time in improving this availability. To improve this availability, we have, backup of everything. Like even our servers can be backed up. Even our database should have a backup. Let's say one database is not available, we should have another database as a backup thing. So maintain this availability, especially with the bigger 999. We need to take a lot of measure to make sure we are, giving a good customer experience. And to achieve this extra 9, it is actually 10x harder to achieve this. Like just to improve this 0.90009%, it is 10x higher to achieve that. So keep that in mind. I hope you got what does this availability means and how important this terminology is. Now, the other important term is actually reliability. Reliability. What does this reliability means? So let's take an example. Okay. You have your own bank app. Like this is a banking app. Okay. You wake up in the morning and you see, hey, my balance is $0. But like just this morning, you get a credit of $5,000 as your salary. But this $5,000 is not even showing. It's not even reflecting in your app. So what you will do, you will start panicking out. You will say, hey, why my app is showing $0? Why not it's showing $5,000? I have got my money. I have got my money. So we will talk to customer support. Then customer support will check in the database and they will say, hey, you know what? In our database, it is actually correct. It is just our mobile app is not showing the correct data. Maybe some issue is happening. Now, this is a reliability issue. Like if you compare it with availability, let's say if in this you wake up in the morning, if you are not able to access the app, let's say you are not able to access the app, this is actually much better than seeing a wrong number. Because you open the app is not working, you will like, okay, might be some issue, I'll check in 2-3 hours. But let's say the app is actually working fine, that means availability is good. Availability is a green tick. It is 99.999%. Availability is good. But you open the app, the number here is correct. And this is a banking app. This is a very crazy, tragic thing. So you can't even afford it to give this experience to user. So reliability is actually very, very important in any kind of system that you are developing. It is very important even than availability. Availability user can, just ignore for a moment. But reliability, it is a known trade-off thing. So basically, what is availability and what is reliability? Availability means it is responding. It is actually responding. But reliability means responding correctly. Like correctness is a very important thing here. I hope you got it. So we'll discuss how to improve the reliability in a later down the module when we deep dive into everything. But the thing is that reliability is actually more harder to achieve than availability. Availability just needs some backup servers, but reliability needs like if multiple servers are there, all server needs to say yes to same thing. Like it's not like that one server is saying something else, another server is saying something else. It can't be like this. If multiple machines are there, all multiple machines need to have a same kind of opinion on a value or something like that. So achieving reliability is actually more effort than availability. We'll discuss both of these things in a later down the line, but I hope you got this point. What is availability? What is reliability? Now, another term is actually scalability. Okay, there is another term that is called scalability. Now, what does the scalability means? Scalability is nothing but, let's say, if you made an app, okay, you made an app, and this app got popular. If you made an app such that it is scalable, then let's say if you are having a 1 million of user, it won't even crash. But let's say if you are not thinking about scalability, then even with 5,000 user, your app is getting crashed. So scalability means the more traffic your system can handle. The more traffic your system can handle, the better it is, the better user experience it can give. And scalability we can achieve by two ways, either by vertical scalability or by horizontal scalability. See, I'm just touching the base of these terms. We are not going deep dive. I'm just telling you these terms exist. We'll deep dive in the next module. But scalability means it can handle more traffic. The more traffic, the better profits, the better user experience, better everything. And how we can achieve scalability? By vertical or horizontal. Vertical means we are increasing the size of computer. Let's say if earlier you have a 16 gigs of memory, now you are having 100 gigs of memory. So I've increased the size of a computer. Horizontal scalability means if earlier you have one computer, now you have 2 or 3 or 4 computers. So scalability can be achieved by these two methods. I'm not going deep dive. I'm just giving you the high level overview, what exactly the scalability means. So I hope in today's lecture, you got the crisp of all the vocabulary that we are going to use in our upcoming system design course. Like, what exactly is percentile. If someone is asking about the latency, you have to tell the tail latency. If someone is asking what exactly is the latency, what exactly is the throughput, you have examples, you have knowledge of each and every terminology now. Availability, what is availability? What is reliability? What is the difference of 99 and 99.99%? There's a huge difference. You have already seen that. So I hope these things made the foundation covered. In the upcoming lecture, now you will enjoy more because you know the terms and you will learn more. I'm super excited to see you in the upcoming lecture. Thank you so much for being with me.